Let us solve the exercise number 6 in the part B of data structure lab. In this exercise, we are supposed to write a program to implement a circular queue using arrays. So let us first try to find what is a queue. And if you try to search for an image in queue, queue is nothing but a people or any object that is standing one after the other. So it is a list. So in this case, it is a list of persons who are standing one after the other. Some of the quality of the queue is whenever we talk about the queue, the first person to arrive in the queue is the first person to move out, and the last persons always enter or come into the queue from the rear side. So people exit from the front side. So this is the person who came first. The front side is the person who is going to exit the queue, and the rear side is the place where the new person will arrive at the queue. So that is the idea of the queue. So this is the suppose if you are staying in a, or you're going to a shop, that is if you're buying some grocery item, the first person in the queue will be served first. So this is the front side of the queue where the exit happens. This is the rear side of the queue, that is where the new arrival happens. So this is the idea of the queue. Now coming to the circular queue, what is the difference in the circular queue? In the circular queue, the items or the elements that you are going to add, they will add one after the other. So you go on adding them, and the speciality of the circular queue is after the last item is added, the queue retrieves back to the first. So it looks like as though it is a circle. So you start adding the first element, you add the second element, third element, fourth element, fifth element. If there is a vacancy, the next element will go next in front. So this is what is the queue. So it is like a circle, you keep on adding. Then if there is a vacant place at the front, you come back and still add, starting adding from the front, and you keep on doing it again and again. So this goes in circle. So this is what is the idea of a circular queue. For example, you have a vacancy here, so you have added the first element, second element, third element, fourth element. Now there is a vacancy here, so you add the fifth element, let's say. Now this queue is full because there is no more space that is left. If suppose the first two elements are deleted or vacated from the queue, so you still have two vacancy here. So what will happen in a circular queue is the next element is added to the first position. So it will add it to the first position, and the next element will be added to the next available vacant. So in other words, this queue will keep on rotating in a circular manner. So that's the idea of the queue. Now let us come back to the few details about the queue. Initially the queue will be empty. So what is the meaning of saying the queue will be empty? There is no first position, no last position, because nobody is there in the queue. How do you say that the queue is vacant? Because we are to implement this queue using an array, and you know very well array index starts from 0 and 1 2 3 4 and so on. Array always the index starts from a of 0, a of 1, a of 2 and so on. You are familiar with the array index. So index starts from 0. So we say that the pointer, that is the front and rear, are not pointing to anything on the queue. And you know very well the queue values are 0 1 2 3 4. That means 0 or any positive value. So array index cannot be negative. So we just say that both the front and rear are -1, indicating that they are not pointing to the array. That, in other words, in terms of queue, we are simply saying that a queue is there is no element in the queue, so I cannot decide who is first, who is last, or who is in the middle. So that is the meaning of saying the queue is empty. So let us start implementing this part. Now I'm going to go to the, going to close this thing. I will go to the file, and I'm going to start a new file over here. So I'm going to go here, file, and then say new file. This is the longest way of doing it. Shortest way is just click on the file and new. By the way, I'm using the code block for implementation. Code block is freely available. You can download it. It's an open source, so you don't have to worry about the uh, copyrights and other issues. So let's click on to the C and C++ code. Let's go to the next one, and I'm going to implement it using C. Let me go here and let me click on the new place where I'm going to use it. I'm going to say cirq. I have many demonstrations, so definitely you will find that name is already there. I'm going to use some name. You can use exercise 1 2 3 4, anything is okay. So just start creating one file, and as usual, you know very well, because I'm going to input something, I will use stdio.h for my input output operation. Let me define the size of the queue. So I'm going to say define the n. I will not, some people write it as size 5. I'm not going to do it. I'm going to use a single letter n equal to 5, because I assume that you are going to do it for the examination, and during the examination don't write too lengthier variable name or any lengthier function name, because you have to write it first and then type it. So it's going to take a slightly longer time. So always try to reduce the variable length and other things, so that it is faster and you can implement the things faster, as well as you can write it faster. So let's go ahead and let's start implementing the queue. I will take the queue as integers with the n elements, and the n is defined as 5. Let us take the first thing. What is the first thing? I said that in the beginning, the front and the rear are -1. That means to say that queue is perfectly no elements are there in the queue, and the queue is empty, and this is the condition we are going to check whether the queue is empty. Whenever we say that the front or the rear, any one of them you can take it, if the front is -1, queue is empty. This is the condition to check whether the queue is empty. So I'm going to do that thing. So I will write a function called as is empty. There is no need to write this function, but I will just do it, because some examiner say that you have to write that function. Is empty is nothing but you are going to just return whether f is equal to -1. Remember, here you are checking, you are assigning f equal to -1 means you are assigning a value 1 to f double equal to -1 means you are checking whether the value of f is equal to -1. The answer of this could be either yes, the f value is equal to -1, in that case it is true, or you say no, the value of f is something different from -1, in that case you will return false. In any case, you are going to return either true or false. So this is the condition where you say the queue is empty. When do you say that queue is full? The exactly opposite of it. The first thing what we seen is the queue is perfectly empty. When do you say that the queue is full? So what is the criteria when you say that the queue is full? Now you just look at this circular queue. Just look at this circular queue. You keep on adding one element, second element, third element, fourth element, fifth element. Now remember, this is going in a circular queue, so it is going in circle. Okay, if you find that the next element is the front, so this is the front that I have taken, this is the front, and this is the rear. If you find that the next step, if the rear takes the next step, and if it encounters the first, so that means to say that the queue is full. So whenever the rear pointer or real value or the rear position, if it takes when it takes the next position or the next step, if it encounters the front, so in other words, if the front is in if the f or the front position is in front of rear, or in other words, f is in front of r, or when r takes next step, if it encounters f, then you say that the queue is full. So let's look at let me just give you an example over here. So just say that so you are adding, so just don't worry about this 1 2 3, just pretend as though you are not seeing this 1 2 3 4, because otherwise the things will become very lengthier. Okay, so just assume that this is the thing. So you have 30 40, I'm just giving the value, the elements are a b c d, it could be a b c d also. So just look at this one, just assume that I'm not going to give these values, just for the time being, just ignore this. Okay, word, please don't scroll to the next page. Okay, okay, so so this is the current scenario. You have the element in the front, you have the element in the rear. Okay, now let me just assume that the first element is gone, you have deleted the first element, so first element is gone, the front is in here. Let me assume that the second element is also gone, so the second element comes here. Now if I want to add some element, so what are you going to do? If I want to add some element, remember the rear will come back to the front, so this is a circular queue, there is a vacancy here, so rear will come and shift to this position. So let me add one element here, say 60, and there is a vacancy in between. This is front, this is rear, there is a vacancy in between. Let me add one more element, so this is the place. Now you notice that you 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 have added sorry about that, because I'm not doing it because Microsoft Word thinks that I have to go to the next page somehow. Okay, so this front is there here, and the rear has come to this position. Now if you try to add one more element here, you will notice that it is not possible, because there is already something in front. So this is the front here, so front is here, and the rear is at the back of front. So that is where you say that the queue is full. So what is the criteria? When the rear takes one step, and the next step of the rear, if it encounters front, then we say that the queue is full. So that is the scenario. Now the next question is, how is it possible that the rear, which is pointing to this location, the value of rear is this, I'm taking, what is this 4 that I have mentioned here, is 4 is the index value. Array, you know very well, array starts from 0, a of 0, a of 1, a of 2, this is the array. So you have written array, just recall. So in your C program you have written a of 0, a of 1, a of 2, like this you have written like this. So this is a of 0, a of 2, a of 1 2 3 4. So the array is full now. Okay, how will you bring it back to the front position? So r is 4 now, because it is pointing to this location. How are you going to bring this r back? So the easiest way is count how many elements are there. 1 2 3 4 5 elements are there. Index is 4, but totally 1 element, 2 element, 3 element, 4 element, 5 elements are there. 5 elements are there. So you take what is the position of r. R current value of r is 4. Add 1 to it, so it becomes a 5. Okay, so you get this one. Add 1 to this, so this you take it, and then perform the mod operation on it. So mod of 5, so this is 4 plus 1 is 5. Okay, mod, this is mod 5. What is the meaning of saying mod? Mod will return remainder. So 5 goes 1 times, you take 5 by 5, 5 goes 1 times. Okay, this is the quotient. What is the remainder? Remainder is 0. Okay, if you take 4 by 5, just recall 4 by 5, what is 4 by 5? 5 does not divide 4, so the quotient is 0. What is the remainder? Remainder is 4. I'm talking about the remainder. So 5 divides it 1 times, remainder is 0. So what is the value if you assign this value to r? So what is the value of r? R will become 0. So what did I do? Last value of r, what was the last value of r? That was 4. So last value of r plus 1 divided by the size. So size, I've taken it as n, size of the array. So how are you going to do it? So last value of r plus 1, okay, mod, so this is not division, mod size of the array. So this is how, if you do this, it's going to trace back. So this was 0 here, it was 4 here, it becomes 0. That means to say that r will simply start pointing to the first location, that is the index 0. So this is what you are going to do. So what is our idea? How do we say that r will keep on rotating? Is we say, what is the thing that we are going to say? We are going to say new value of r is equal to old value of r plus 1, okay, mod the size of the array. So this is what we are going to do it in our program. So now let us come back to the story. What was the original story? Original story is whenever you find in any scenario, if you find that the f is in front of r, in this case you find that f is in front of the r, you say that the queue is full. So let us write this code. When do you say that the queue is full? So I'm going to say int is full. What is the scenarios? The scenario is you are going to say check whether the next step of r is, if the r takes the next step, you notice that if the r takes the next step, it must encounter f. But what is the next step of r? I have already told you, next step of r is not r is equal to r plus 1. This is not the step. R is equal to r plus 1, we are not doing it, because if you take r is equal to r plus 1, the r value, when it goes to the last element, it will not come back. It will not come back. How will you make it to return back? If you want the r to come back, then what is that you have done? You say that r is equal to r plus 1. No doubt r will take the next step, because you want the r to come back, retrace its value back when it encounters the last element of the array. You are going to use mod n. What is n? N is the size of the queue. This is the idea. So you don't say, generally what you are just saying, what is the next step? Suppose if you say I, suppose if you take I is equal to I plus 1. This is the general next step. Generally what you say is the next step is plus 1. But in this case it is not just plus 1, it is mod n, because when you encounter the last position here, you want to come back to the first position, because it is a circular queue. So you must say that the next step of r is not r plus 1, it is r plus 1 mod n is the next step. When you encounter the next step, when r takes the next step, if it finds the f in front of it, you say that it is queue is full. How can I write the same story here? So I'm going to say return, when r takes the next step. I'm going to put it in bracket here, just to make it realize the compiler will not mind me doing it. When r takes the next step, so how can r takes the next step? You say r plus 1, but that's not the end of it. Mod n, remember this is how the r takes the next step. I already written here. So r is equal to r plus 1, not the end of it, r plus 1 mod n. Remember this is the step that I have written. If this is, sorry, if this is equal to f, so in other words, when r takes the next step, when r takes the next step, if it encounters f, then the queue is full, otherwise the queue is empty. So what is the result of this? The result of this is when r takes the next step, it may find f in front of it. In that case, it's going to return true. Or when r takes the next step, it may not find the f. For example, in this case, suppose if there is one more vacant cell here. So if there is one more vacant cell here, when r takes the next step, suppose if r takes the next step, you notice that there is a vacant here. So in this case, you cannot say the queue is full. In this case, the queue is empty itself. So there is one space here. But in the previous scenario where suppose say if the r goes here and one other element is put here, in this case when r takes the next step, you say the queue is full. So hope you got the idea. When do you say r is empty and r is full? Now let's look at the next one. See, generally we use two words. This is very dangerous words. We don't use these words. One is NQ. Q. Where is the Q? Okay, NQ. Other one is DQ. Now, during the examination, if you don't remember these words, because we know that we are not good in English, so you just say insert. Okay, the complicated English word for that insert, simple insert is NQ. Okay, if you don't remember that word, just put insert during the examination. So don't need to worry about it. Insert, delete, list or display will work. No examiner will find fault with you. They will not tell you, no, 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 you have to use that word, because it's okay. At the end of the day, you are inserting it. But I'm demonstrating it. That is why I'm using this word. But I don't like to use that word. Okay, it is a bit a scary word. So I want to insert a value into the queue. So how do I do that thing? Now let's come back to the story here. I want to insert a value into this queue. Okay, the queue is perfectly empty and I want to insert the value into the queue. Okay, so if I insert a value here, then both, remember, both the front and rear was -1. Both the front and the rear has to be touched and you have to make them as a 0. So for the first element that you are inserting, if it is the first element, you have to change both the front and the rear value to f, because both front and the rear were -1. You have to touch them. Okay, what about the next element? Next element, if you want to insert it, then don't touch the f, just increase the front, sorry, the rear. Don't touch the front, just increase the rear. So how do you increase the rear? Remember again, to recall, how do you increase the rear? Rear increment is not r is equal to r plus 1. This is not the case. Remember, r is incrementing how? R is equal to r plus 1 mod n. This is because you want the r to come back to the front. So increment is r is equal to r plus 1 by n. N is the size of the array. Okay, this is it. Now the question is, so if the queue was perfectly empty, so that was this case, when both r and when r is equal to -1 and f is equal to -1, this is the initial stage. That is where we have started our coding. We said that initially both r and f are -1. Well and good. So we started with that. So when r and f equal to -1, the queue is perfectly empty. Good. But always remember this thing, whether it is a array, whether it is a stack, whether it is a queue, or whether it is something else except the linked list, which generally has an option to automatically start increasing. But the generally fixed structure, whenever you are using, before you insert, this is the general thing you must always remember. Before you insert, check whether it is full. So what did I say? Before you insert, check whether it is full. If it is full, like this is the case. If it is full, you cannot insert anything. So this is a caution that you have to follow. Don't expect that there is going to be a place here. Okay, if it is full, so it's like you are you want to travel and morning you are catching bus and you are going to your college. If the bus is full, you cannot you enter into the bus. So that is simple as that. So before you enter, you just check whether the bus is full. You don't enter the bus and then check whether there is a seat or whether something. Okay, so before you insert, check whether it is full. What is the exactly opposite of this? Before you delete, you check whether there is any element left over. So two things. What did I say? Before you insert, check whether that thing is full. In this case, queue is full. This is before you insert. What about, what is the opposite of this? Before you delete, that is before you remove, check whether there is at least one element in that queue. So you cannot remove. Suppose somebody says, okay, you remove an element from this queue. Which element will I remove? Because that queue is itself is empty. So before I remove, I check whether the queue is empty. Before I insert, I check whether the queue is full. So two things you must do it. Okay, so let us start writing it. I want to insert an element, general element. I am going to call it as val. So any element I can insert, 10, 20, 30, anything. I'm just calling value. I want to insert some value, val. It could be, it is a variable, it can take any value. So I want to insert this. That is what I have written. So I want to insert a value into my queue. So this is what I'm doing. Now what is the first thing that I am supposed to do? I have already told you, before you insert, so you check, before you insert, check whether is it full. Okay, what is this? So is full, I have written. I have already checked this one, is full. Okay, how do you say? If R takes the next step, if it encounters F, that is full. If the queue is full, there is no way you can do anything. You just use the printf statement and you just say queue is full. Queue is full. Okay, if you can't type, just say full. Just use the word full during the examination. Don't write, some people say queue is full, so you can insert an element. Don't write, don't waste your energy in typing all those things. Just say queue is full. And I'm going to use /n, so just so that it just goes to the next uh, place. So you know, /n is next line. Okay, otherwise let's go with the other story. Otherwise, what are you going to do? Otherwise, you have to check whether the queue is empty. There are two cases. Remember, first check whether the queue is full. If queue is full, you are luckiest one. There is nothing to be done because you can't insert it. Otherwise, go to the first scenario. If front is -1, remember you can even check for the R, but I will check with only one. If front is -1, you have to make both front and rear point to the first element. Remember, for the first element, if you are inserting, you have to make both the front is 0 and rear equal to 0. This is the scenario only for the first element. So when you encounter the first element, let's say you are inserting some value, I'm going to just say val, some value you are inserting. So but the first value that you are inserting, you have to touch both f and r. So let's look at this one. If, okay, if front is equal to -1, that means if the front is, this is the first element that you want to insert. Did I put too many? I will remove one bracket. I think I put two bracket here. If it is equal to -1, what are you going to say? You are going to touch both front equal to 0, front equal to 0, okay, and the rear is equal to 0. You touch both of them, front is equal to 0 and rear is equal to 0. You do that thing, but that's not an efficient way of doing the thing. Otherwise, you will write like, otherwise you see, otherwise you have to increase the rear. That's all. For the next element, just increase the rear element and keep on adding the element. Okay, so only for the front, the first element, you have to do it. Otherwise, remember, front will come 0. This is r is the one that will keep on increasing as you put more and more element. So this r will have to keep on moving. So the front will move only when you're deleting it. When you're inserting for the first time, front will move. So if the front was -1, it will move. If the front was -1, it will move here, and you are going to set the value as a 0. You're going to do it. But whether it is -1 or +1, when you are inserting, the rear will start moving each step. So it will keep on moving each step. So what I will do is just change. This is the general scenario that you are doing, but I'm going to slightly modify this. See, I'm going to touch only the front. I'm going to say I will set the front is equal to 0. So what did I say? If the front is minus 1, so this is a scenario. If the front is minus 1, let's say rear is also minus 1. Okay, I will just make front is equal to 0. Okay, front is equal to 0. That's it. What about the rear? Rear is the general case. Rear will increment by one step. How do you increment a rear by one step? You know very well, rear is equal to rear plus 1 mod n. So you know very well, rear is equal to rear plus 1. Okay, I'm going to write it there because this will not do it. So general, what did you say? Rear is equal to rear plus 1 mod n. This is the general thing you are going to write, is it not? So rear will increase on its own, whether you insert it in the first element, second element, third element, fourth element. Rear will keep on incrementing whenever you are inserting it. When you are inserting, rear will have to go to the next step, is it not? If the rear is here, let's say if the rear is here, it will go to the next step. So how do you say rear will go to the next step? So remember, this is the if is only for the first element. Rear, whether it is a first element or next element, whenever you are inserting, rear will have to increase by one step. So this is regardless of your status. When you are inserting, rear will have to move, otherwise you can't insert it, is it not? So this if what I have written is only for this one, whether it is the first, whether it is the last, whether it is the middle, rear will always increase. So this step, don't consider this as part of if statement. This will keep on doing it without any problem. Okay, that's it. And how do you insert a value? You just go to the cube, and the q of rear is equal to whichever value you have inserted. And I'm going to just give a statement to the user saying printf, and I'm going to say inserted. Some people will write inserted percentage d slash n lengthier, making the word lengthier value. Okay, because some people expect you to show which element was inserted. I'm going to just do it because I'm doing it, but personally I don't like to write this printf statement. Just to say inserted is enough for me, but some people will say that no, you just as a good person, you just say that which element was inserted. So you just say inserted whichever value that was applied to me. So this value was applied to me to this function. Okay, and I'm saying that value, if this value is 40, I'm going to say inserted 40. Whichever value you have said, I'm going to insert that one. So this is for the NQ. So similarly, see, these English people have brought some other words there. So insertion is nothing the NQ. This word that I used, the NQ, is nothing but insertion. What about deletion? The English people say that it is not a deletion. You cannot say it is a deletion. You have to say it is a DQ. Okay. Again, during the examination, if you just forget what was that golden word, just write delete. Okay. Don't worry about it. Insert, delete. It's simple as that. Okay. If you remember, well and good. If you don't remember, the one is you are inserting, the other one is you are deleting it. Okay. So when you are deleting it, remember, we don't say delete the value. Deleting, what is the meaning of saying deleting? Deleting is you are just moving the front by one location. So you just if the front is here and rear is here, let's say, you just move front by one location. That's it. So you move the front by one location and say that you have deleted that thing. However, there is the one other thing that you must do. If it was the last element that you were deleting, so what is the meaning of that? So for example, front was here. Okay, this Microsoft Word, I don't know why it is behaving like this. Let me just zoom in and let's make it not to scroll to the next it is where is it? Let's see. I hope that it will not, this time it will not do it. So you, let's say you deleted the 60. and when you delete the 60, the front will go. Remember, in the queue, front side you are deleting it. So you want to delete the next element, move it and delete the next element. You want to delete the next element, move it and you delete the next element. You go to the next element and you delete the element. Now what you notice that both R and F are pointing to the same location. Both F is pointing to the same location, R is pointing to the same location. What is this scenario? This is see this Microsoft Word. See what a nonsense software is this. So this particular thing you notice over here, this thing you notice here is both F and R are pointing to the same location. Yes. So what is this case? This is a very special case. What is this special case? There is only one element left. You notice that there is this is deleted, this is deleted. All the elements are in the queue are deleted. Now you are left with the only last element. If you are deleting this element, what will happen? If you delete this element, if you delete the last element, queue becomes empty. Sorry, I tried my level best to avoid it from scrolling, but it will scroll because the software is written in such a way that it has to scroll and disturb me. Okay, so in any case, I will come back to the my explanation here. So if you delete the last element, the queue is empty. When do you say that queue is empty? Let us recall, when do you say the queue is empty? You say Q is empty whenever both R and F are -1. You notice that story. So if the Q is empty, then you will have to reset both the F value equal to -1, R value equal to -1. When did it happen? When, sorry, let me come back to here so that it won't scroll here. So when you find that both the, let's assume that this is deleted, this is deleted, this is deleted, this is deleted, both R and F, let me just make it a point like this. Okay, both R and F, okay, are pointing to the same location. Both R and F are pointing to the same location. That is it. And that means to say that there is only one element in the queue, and you are now taking the step of deleting. You dare to delete the last element. If you dare to delete the last element, if you are deleting this, then you have to reset it both this and this. Remember that if it's the last element, reset both F is equal to -1, R is equal to -1. Remember, when you say F is equal to -1, R is equal to -1, what does this mean? This means to say that the queue is empty. Both F and R are not pointing anywhere in the queue because there is nothing left in the queue. Okay, so if you are deleting, reset both R and F. So let's write that thing. But we will start with the first caution that I have given you. What was the first caution? Before you insert, check whether it is full. Before you delete, check whether it is empty. This you cannot forget, whether it is a stack or whether it is a queue. Before you insert, check whether it is full. Before you delete, you check whether it is empty. So if it is empty, okay, like this what you have done, if it is full, you say q is full. If it is empty, you are going to say print f, and you are going to say q is empty. Okay, slash n. So in the previous case you said q was full. Here you are going to say, if it is empty, you say q is empty. There is nothing you can do. Okay, is it not? Then okay, so we want to delete the element. So it is not empty, we want to delete the element. Remember, which element are you going to remove? The element whichever is in the front, whichever front is pointing. Remember, in the queue you are deleting from the front. So we are going to first give a printf statement saying that we are going to delete this statement. Okay, so we are going to say that we are going to delete it. Okay, percentage d slash n, we are going to delete, we are going to give the message here, because after deleting we don't know, the element is gone. Before we delete, we can just catch hold of the element. We can print it afterwards. Remember, once it is deleted, you don't know which element is deleted. So before, I have not deleted it, I am just showing on the screen that I will delete it, even though it is not deleted. But just say that it is deleted, because I'm going to delete that element which is pointed by the front. So whichever element that is pointed by the front will be deleted, because once you move the front, you cannot catch hold of that element. It is gone because front is gone. So before I delete, I just say that I have deleted that. Okay. Now now when you delete it, two things you must do. What is the two things? If front is equal to rear, remember what, when you encounter this case, when both front and rear are equal, front and rear are equal, when it is the last element that you want to remove. Remember, if it is the last element, suppose if this is the last element anywhere, I'm just saying. So here front is pointing to 4, rear is also pointing to 4. Okay, let's say there is some element, some value is there. Let's assume that some value is there. You want to delete this value. Both front and rear are pointing to the same location. If you delete this value, if at all you delete this value, then both the front and the rear must be reset to -1. Okay, why? Because you then say that q is empty. You just bring them back and say that q is empty. So this is what I'm going to do. If the front is equal to rear, then you say that front equal to -1. I'm going to do like a old student. Rear is equal to -1. So old school. So equal. Let me put equal to. Is there a other way around? Other way around is, I'm not going to do it. I'm not going to confuse you. You say front is equal to rear is equal to -1. Okay, this will work. Okay, don't worry. You can avoid writing one step, but I will write it a lengthier one, because just to make it go with the flow. Otherwise, you just move. If it is not the case, if it is any other case, how do you move it? For any other case, you just move the front by one step. If the front is pointing here, take it to the next step. So if the front is pointing here, and if you want to delete the 10, you just move the front and make it go to the next element 2. So this element is deleted. Remember the very important thing. Now I will zoom out and then bring it back to you. So this is the, see, the same story happens with the rear. You delete rear, will go to the next. You delete rear, will go to the next. You delete rear, will go to the next. Again rear will come back. So how the front is go returning back, similarly the rear, how the rear is moving back, similarly the front has to also move back. Remember, both the front and the rear are going in circle. So how do you make the rear go in circle? You know very well. You don't say rear is equal to rear plus 1. You don't say this. But what is your new way of saying it? Rear is equal to rear plus 1 mod n. N is the total number of element. In the same way, you don't say front is equal to, if you want to move the front, you don't say front is equal to front plus 1. This is the old school of way of doing it. Now when do you, how do you say then you say in the new way, you say, because it is a circular q, f is equal to f plus 1 mod n, because you want even the f to come back and retrace its path. So it f also has to go in a circle. So how do you say that thing over here? So you don't say f is equal to f plus 1, but in the new way of saying is f is equal to f plus 1, not the end, mod n, where n is the total number of elements. This is what we have done. So this where is it gone? Let me remove unnecessary spaces from here. Okay, done with this. Let's go with the next one. How do you display the element of the queue? So how do you display the element? Remember, in order to display the element, you find out where is the front, where is the rear. So where is the front and where is the rear? So you just say some elements are there. I'm just putting some elements. Okay, some elements are there, so this f is there. Okay, you just start from the rear. Let's say this front, you just start from the front. So let's say you start from the front, you keep on, you start from the front, this position, you keep on displaying one element, show one element at a time until you reach the f. So first show the 10, next say 20, 45, next say 56, next say 66, next say 77, and this is over. So you start from this front location, wherever is the front location. Front location need not be here. In this case the front is this location, so front can be anywhere, wherever is the front. You start from the front. So let's say this is 0. Okay, 0. So you start from the front location, you go up to the rear location, start from front, go up to the rear location, and go one step at a time, and then start showing all the elements until you encounter R. So that's it. So let's look at this function. You can call it as a list, or you can call it as a display. I will call it as a display. Okay. Let me call it as a display. Did I use the capital? Okay, my first letter was non-capital. That is why I am using. So why did I? If you're wondering why this person typing everything in small case, because I started with all small cases for function. So I'm just using that same logic. So first one is whenever you want to display it, you just check whether, see, you can display the element provided there is something in the queue. In this queue, what will you display? And there is nothing in this queue. This queue is perfectly empty. If this queue is empty, can you display anything? When do you say queue is empty? When front is equal to -1, and you know we have already written a function for that. So we will first check whether the queue is empty. So how do you say that? If is empty. So if the queue is empty, there is nothing. You are the luckiest one. So you don't have to do anything. You just say printf, and you just say what you can say, queue is empty. What else you can say? Queue is empty, and slash here. Done. So this is easiest one. But what is the toughest one? Otherwise the story has to be done. Otherwise, how do you say that? You create a variable. Let's say int I. I'll take the value. You know, I is equal to I plus 1. You are doing that. So I take the counter value I. Remember, I must start from F. You are starting from F. This is what I told you. You start from F and start showing 1. So I will take the value 0. Then I will take the value 1 and show whatever is there. Then I will take the value 2. So whatever it is there, I is equal to 3, show whatever it is there, I is equal to 4, show whatever it is there, then it is the end of it. So you start doing it from there. So I'm going to start showing all the element. I will use the do while loop here. So I will use the do, okay, while loop. So how do you say do while loop? So do while, so I'm going to say do while, what is it? I is not equal to, remember, this is not 1, this is I. Remember, don't confuse, this is I, the one that I've used. I is not equal to the next element. Remember, I will start from here. I will start from here. I is equal to 0 initially, then 1, 2, 3, 4. Next step, I should stop. I should not take the next step, because that's the end of it. When it encounters R, next step it has to stop. So it has to reach till the R and show all its value, and the next step it must say that next step of R it should not show. So next step of R, how do you say next step of R? Next step of R is not again R plus 1. This is not R plus 1. Again and again I am reminding you, what is the next step of R? Next step of R is equal to R plus 1 mod n. This is the next step of R. Remember, next is not R plus 1. Next step, I should not take the next step of R. I must stop at R location. It should not exceed the R location. So I should not exceed the next location. Remember, it has to show till the rth location. Rth, if you are using English. Okay. Then the next step it should not take it. So that is what I am going to do here. So I will say that I should not take the next step of R. How do you say that? R plus 1, next step of R is R plus 1 mod n. I should not take this value. Okay, this is it. And what are you going to do inside this do while loop? You're going to show each and every value. That's it, simple as that. Print f. Okay, some people say content in the queue. If you want to say show that thing, I am writing the examination, so I don't want to show all of the contents in the queue, because the program itself says show the queue value of the queue. And I'm going to use the slash t tab separation. Some people use space separation. I appreciate the people who do that thing, because it comes very beautifully. This tab may be give you slightly longer distance between the element, but it's okay. Okay, you show the ith element. So the what is this q of I? So when I is equal to 0, you show q of I, that is it. When I is equal to 1, you show q of I, this is 45. When I is equal to 2, you show the value of q of I, whichever value of I is there, you show the value of q of I. That is what I'm showing. I'm printing the value of q of I. Okay, and you have to increment. Once you print the value of I, when I is equal to 0, you print the value. Then I had to go to the next step. How do you go to the next step? Remember, in the queue, next step is not I is equal to I plus 1. It is not that I is equal to. So when, because we are talking about the queue, in particular the circular queue, not just the ordinary queue, it is I plus 1 mod n. Remember, why? It has to retrace it back. Otherwise what will happen is I will keep on increasing. I don't want that thing to happen. When it encounters the last element, it has to come back to the front. So it has to keep on going to the next element. And when you reach the end, you should not go beyond the array. You have to come back to the previous that is the first location of the array. And how do you do it? You know very well. This is the idea. I is equal to I plus 1 mod n. So this is done with our case. Now let us write the main function. So I will remove some spaces here so that it looks nice. Okay, unnecessary enter was there, so I just removed the enter. Let's start with the main. I'm going to use the void main. So I'm going to use this void main. Let us use the menu driven option. So in the menu you will ask the choice, enter your choice. You know very well, my choice, initial choice is 0. Okay, so I don't want to do anything. And you know very well, we have to insert a value. So I'll assume that that value is val. Now you know I have inserted the value val here into the queue. So that value, let us say I'm going to take that value from the user, and I will use a while loop. While you keep on showing this menu I am showing, while the choice is not equal to, what are the choices? Say I'm going to give the user a choice. Choice number 1, insert an element into the queue. Choice number 2, delete an element into the queue. Choice number 3, list the element of the queue. Choice number 4 is my favorite one, exit out of this program. Okay, so when you say choice number 4, you will stop this menu. So until it is not 4, until your favorite number has not come, you have to uh, iterate over all the choices. So I'm going to say, while choice is not equal to this, you will do that thing. So let's start with the printf statement, and I'm going to give one heading here, slash n, maybe slash n, one more slash n, and I'm going to say dash 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 circular q, circular, is it spelling is circular q. Okay, maybe dash 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 dash. Okay, so simple. Okay, so it looks beautiful. Okay, choice, let us put some choice, print f, let us put some choice to the user. The choice number 1, I have told you, choice number 1 is insert, but English people don't like that me writing this one, so I will say nq. Okay, slash n, choice number 2, where is the choice number 2? dq. So my, if you allow me, I will write delete, but English people don't like that, so I will say choice number 3. Okay, I will put remove a space here, otherwise that space will come. Okay, so Choice number 3 is a display. You can say list also. Okay, done. Choice number 4, the favorite one is, what is this one? Choice number 4 is exit. Okay, though done. After this, I'm going to use a print f. Okay, some dash 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 dash. Okay, some dash slash n, and I'm going to say enter your choice. Enter your choice. Okay, and maybe like this, and one space. Remember, put one space here. Some students don't put at the end, put one space, otherwise they will touch whenever whatever you insert, it will touch. Then I'm going to use a scanf statement. Scanf statement, percentage d, and I'm going to read the choice, ampersand choice. You read the choice. Okay, if the choice is that, you are going to do it. So I'll just show you how this is going to appear, only this part. Circular, if this spelling is proper. Okay, if the spelling is not proper, you go and contact English department, they will correct it. So I have not put one semicolon here, so I've not put semicolon for this one. I'm just executing it just to show you. If there is a, I've not put one semicolon, again missed the semicolon here, semicolon here. Hopefully there is no error. And what is it is saying? Okay, sorry, I put a semicolon here. See, where I am not supposed to put the semicolon, I have put the semicolon, and where I am supposed to put the semicolon, I have not put the semicolon. So this is how it's going to look like. It will take some time for it to compile and run it. So look at how beautiful this is going to look like. So let's see how it has appeared now. So circular queue has then q, nq, dq, display, and this slash n, forgot. Oh, I need one slash n here. So I will put my favorite one to exit out of this. Okay, so the program has exited. Let me just close it, and I'm going to put one slash n here so that it looks beautiful. Again, let me run it, slash n, extra slash n here, so that if you now look at this beautiful thing, you will notice that this is going to look like this. So this is what I really wanted it. So if you put 1, you will NQ, if you put 2, you will DQ, and if you put 4, you will exit. So simple as that. Okay, done. Press any key to continue, and it's over. Now let's it's not over, remember, that's just the menu I have shown you, so don't get excited. Let us start with the switch statement. In that case, switch on the choices. So we have the different choices are there. Choices 1 is for this one, choice 2 for this one. So case number 1, case number 1, case number 1. Okay, case number 1. What is the case number 1? Case number 1 is NQ. Remember, some people, what they will do is, I will just show you, they will accept the value. Okay, so just to say, they will do like this, print f, and don't do it, you can type it, but I will add one extra thing here, print f slash maybe slash n. Let me put enter a number, enter a value. Okay, enter value, I don't know, in English they say enter value. So the scanf and percentage d value, ampersand value, this they will say, and then so you enter a value, you enter a value, and this is the value. Remember, I took the variable here, value, enter the value, and you know very well, you have written a function called as nq, is it not? Nq, you enter a value nq, you enter the, take the value, and you just say nq, and you nq, and you supply that value. Done. Okay, now this problem is good. Problem is, see, you and you took the value here from the user, you took the value, is it not? Okay, suppose if the queue is after you have taken the value, now it is like you have taken the money from someone, and after taking the money you find that the queue is let's go to this nq, the queue is full. Now you say that no, 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 so queue is full, take back your money. So what the people will say? See, before was you before taking the money, you just see whether the queue is full. Don't take the value and then come out and say that no, queue is full, I can take the value. So it's not ethically, it is not correct. You don't take the value, you check whether the queue is full. If the queue is full, just exit. You say it is not possible. It's like you take the value and then you come out and then say that no, the queue was full, sorry, that we have taken the value and like that. So I am going to put one small check here. Some people don't like this, but I feel ethically that is correct. You don't take the value and then struggle and say that it is a thing. So I'm going to say if is full. If the queue is full, I simply say that this one step I'm taking it. You say that was it is not possible. So I'm going to say some people will now argue and say that then why did you do this step here? Why are you writing this step here? If you are already checking there, why? See, this is a part of your data structure. So in the data structure, I told you what is the first thing. Before you insert, you check whether it is empty. Before you insert, you check whether it is full. Before you delete, you check whether it is empty. This is part of the data structure. Because you are studying about the data structure, that thing is valid here as far as your subject is concerned. So this is a good way of doing it. Whether somebody takes care of or not, it is not the question. You say that before I insert, I check whether it is full. Before I delete, I check whether it is empty. Whether somebody is doing it or not, it's not. If somebody is doing it somewhere else, it's well and good, but on my own I'm taking the action. So you, some people will say why you are writing two-line extra. Two-line extra is required. In my case, this is ethical story, not the other way around. So I'm going to put all these things here. So just drag it and select it, drag it and leave it, and it's done. It's done. So this is the idea. Let me right click and just say format. Right click on empty place and just say format. It will beautifully format the code. Now see, the question is case number one. What is the case number one? NQ. When you are NQing it, you just say whether the queue is full. If the queue is full, you just say queue is full. Okay, queue is full. Done. Was it? You just say was queue is full. I can't take it anymore. Otherwise, you accept the value. So there is no question in doing it. So this is for my case number one, and after that you know very well, because we are writing switch statement, we need a break statement. So then we have the case number two. Case number two is very straightforward. There is nothing much to be done. You just call this a DQ function. The DQ function, I have nothing against this DQ function. You have already written what is this DQ function. If somebody is this is my delete function, this was my insert function. So instead of NQ, you say insert. Instead of deleting, you say DQ. Okay, after that you just put break. Done. What is the next case statement? Case statement 3. What is the case statement 3? Case statement 3 is a, so first one NQ, next one DQ, third one is display. Just call that function. You have already written this function, display function here. Just call that a display function here. So you just say display function. You just say display function and you are going to take a break. Done. Last function, case number 4. This is the most exciting one in the entire program. And what is this most exciting function is choice is /n, and you are going to say exiting dot exiting. We are exiting forever, so we just want to come out of this function, and you are going to use the break. Suppose so there are some people who are there who don't know which number to enter. They will enter anything and everything of their choice. If they enter anything apart from this 1 2 3 4 choice that we have given only 4 choice. Some people are there who will print it, who will try to uh, fool us by giving different values. So we are going to say for anything else we will use a wrong choice. It done. Okay, let me okay, done. So I think everything is proper. Let's do it. Let's do, I'm removing all the spaces. I'm just pressing backspace so that unnecessary space if it is there. If it is there, I will remove that unnecessary extra line space is there. I'm just removing it so that it just comes proper. Again, if you find that your code is not properly formatted, just right click and you have a choice of format, use a style, and it will format and make it a beautiful looking code. Okay, done. Save it and let's look at our queue. Assume that I have not done any mistake. Let me compile and run it, build, and I have made a mistake. And I know you know very well, I wherever the semicolon is required, I don't put the semicolon, and wherever the semicolon is not required, I just put the semicolon. So again, one more place where I have not put the semicolon, just put the semicolon, because I'm talking and I'm typing, my concentration slightly gets distracted. Okay, so this is our queue. We start with the choice number 1, but during the examination or when you are want to write in the record book, remember the queue is already empty. You first display what is there in the queue. It says the queue is empty. You write this choice. Then try to remove an element from the queue. Remember, it is already empty. When I try to remove an element, it must also say that the queue is empty. First two choices there. First, the nothing was there in the queue, and you asked it to show the element of the queue. Queue is empty. Done. Second time, you knew very well that nothing was there in the queue. You just ask it to show me the value of the queue. It just says the queue is empty. Now it is your choice to insert the element into the queue. So you insert the first element. I'm going to insert the first element. How did I type to that? Inserted 16. Just a minute. How did I didn't type to 16 by the way. Not sure. Let me try one more time. I didn't type to 16. In any case, I'm going to type one more. Inserted 16. From where it is taking that 16 one? Let me just go here. Just a minute. Okay, sorry about this. Where it is taking that 16? I'm not very sure. Oh my God. Sorry. See, that is what I told you. When I talk and do it, this is sorry. This is a percentage. D. It is not ampersand. Ampersand is here. Percentage is here. Okay, so this is a percentage D. Sorry, we'll correct that mistake. I think I don't know. I'm not able to concentrate or what. Okay, let me try it one more time. Okay, so I think that's what I didn't type anything there, and it just said 16 is inserted, or who has given you 16. Okay, the my previous choice, first thing you display and say it is empty, uh, uh, and then you try to delete and it says it's empty. Start with the first element, enter the first element 10. Okay, start again, enter the element 20. Okay, start. Some people what they do, they insert 10 and then show in the record, don't show it, insert all the element. So you know that the size of the queue is 5. So enter the element, second element, enter one more element, third element. You don't have to type 10, 20, 30 and something, you can type anything else. Okay, so again enter 40, again enter 50. Now all the elements are there in the queue. Okay, now display it, because 5 elements are there in the queue. Display it. So what is there? All the 5 elements are there. 1 2 3 4 5, all the 5 elements are there in the queue. Okay, so the front one is then. Now it is not the deleting. Again insert it. Remember, the queue is full because 5 elements are there in the queue. Insert one more time and you must get to the familiar message saying that the queue is full. You got the message, queue is full. Now start deleting an element. Delete an element. Only for the first time you say the element 10 is deleted. 10 is deleted. First element 10 is deleted. Now you show the output. It is required to show the output, just to say that 10 is deleted. You see the 10 is deleted from the previous. What was there in the previous? 10 20 30 40 50 was there. 10 is deleted, so 10 is gone. Okay, next time you start deleting almost up to 40, you delete it. So you say delete. So choice is to, remember, to dequeue, the choice is to delete the element. Done. 20 is deleted. Delete the element. 30 is deleted. You see 30 is deleted. Delete the element. one more element, 40 is deleted. Okay, now show the content of the queue. What is the content of the queue? Display, the choice is to display, the choice is 3, so display the queue. Okay, then only one element left over, one element is left. Yes, you delete that element also. Okay, so how do you delete it? You say to choice number 2 to dq, so you delete that element, and now it is over. Now you try to delete one more time, and it must say that the queue is empty. I delete it. Okay, and it says the queue is empty. See, that queue is empty. Now I try to display it one more time, saying that to this is like a confirmation, saying that the queue is empty, and our last favorite choice will come now, and that is exiting. We are exiting out of it. So that's it. That's what you're supposed to do. Just exit the program. That's the end of it. Thank you for your interest. We will meet again in the other exercise. Thank you.